Hello, welcome back. In this video, we are going to look at factor trees and prime factorization. A little bit of definition to get us started. A prime number is a whole number greater than 1 whose only factors are 1 in itself. A factor is a whole number that can be divided evenly into another number. The first few prime numbers are 2, 3, 5, 7, 11, and 13. So you notice there's no 12 here. 12 is considered to be a composite number. You could multiply 1 by 12, but you could also do 2 and 6, and 3 and 4. So numbers that have more than 2 factors are called composite numbers. The number 1 is neither prime nor composite. Prime factorization. The prime factorization of a natural number is when the number is broken down into the product of its prime factors. So to do this, we're going to use what's called the factor tree method. We're going to break it down into its prime factors. So I'm going to look at the number 840. To look at the number 840, I am going to think of 2 things that multiply together to give me 840. You can think of any 2 factors and go with that. Some teachers will say, look at the prime factors. So does it divide by 2? Yes, it does. If I divide it by a prime factor myself, I like to circle it so that I know I'm done. And it would be 2 times 420. Now the 2 can't be broken down anymore because it's a prime factor, but 420 can be broken down, and I can say it's 2 and 210. So again, I have a prime factor. The 210 can be broken down to 2 and 105. Now 105 doesn't divide by 2, so I'm going to try another prime factor. 2, then 3. So does it divide by 3? Yes, it does. 3 times 35, you can get your calculator out if you need to. And then I can check the 35, and 35 is going to break down into 5 times 7, and those are both prime factors. So if I look what I have left, I have a 2 times a 2 times a 2 times a 3 times a 5 times a 7. That is called the prime factorization. And now that we know a little bit about exponents, often what they'll do is they'll write it with exponents. So I had 3 groups of 2, so I'm going to write that as 2 cubed times 3 times 5 times 7. Going to do another example with some big numbers here. Same thing, I'm just going to look for the prime number every time. I'm going to get my calculator out here because these are getting to be some bigger numbers that are a little bit harder to handle. So I'm going to check and see if it divides by 2. Yes, it does. So it divides by 2. It's 2 times 2079. Now the 2079, I can break that down again. Doesn't divide by 2, but it does divide by 3. So if I get my calculator out, it'll be 3 times 693. Now I'm going to look and see if I can break down 693 again. Doesn't divide by 2, but it does divide by 3. And so it'll be 231. I'm going to see if I can break that down again. Doesn't divide by 2, but it does divide by 3 again. So 3 times 77. And the 77 doesn't divide by 3, it doesn't divide by 5, but it does divide by 7. And then we have 11. And also 11 is a prime factor. So if I go to list all my prime factorization here, it would be 2 times 3 times 3 times 3 times 7, I'll circle that, times 11, or 2, I'm going to use the dot, 3 cubed times 7 times 11. And that would be the prime factorization of 4,158. Thanks for watching. Have a great day.